This is the 6th lecture video in week 1 of CS 1030. So we've been looking at pseudocode, and we're going to keep doing that in this lecture. So far, when we've executed pseudocode, we've basically started at the top and executed to the bottom. That is to say, we start at the first step of the pseudocode program. Once we've done executing that step, we execute the second step, then the third, and so on until it's finished. And this is perfectly fine. This is a perfectly fine way to write computer programs, and a lot of computer programs can be written this way. But on the other hand, it's very limiting. There's a lot of other computer programs that we might want to write that can't be written this way. And one of the really powerful things we can add to a programming language that we can add to our pseudocode language that we're talking about is a way to let the algorithm make choices based on circumstances. So let's talk about how that works. So the mechanism we're going to talk about for allowing the pseudocode program to make choices is called selection. And selection allows a choice between two different actions. And the mechanism that we're going to talk about for doing that here has two forms. One of them is an if-then form, and that's shown on the bottom left part of this slide. And the other form is an if-then-else form, which is shown on the bottom right. And we'll talk about these in turn. They're real similar, but we'll talk about them both. So in the if-then form of selection, we have to have a condition that's in parentheses here. A condition is something that's either going to be true or false. So if our program is a game, maybe, we could be asking the question, is the square in the game blue? So if the square is blue, that is to say, if the program can determine that something is true, then we do some action, which is to say, we execute some pseudocode statements that we've written in the then part of the if-then construct. If the condition is not true, that is to say, if the square in the game isn't blue or whatever other condition, then we don't do that action. And either way, regardless of the truthity or falseness of the condition, we go ahead and execute the next statement. So the next statement gets executed unconditionally. And so the next statement here is not part of the if-then construct. The if-then is only the two lines up above it. So now let's look at the if-then-else, and it's very similar. So again, we have a condition. If the condition is true, we do an action, and the action is going to be a sequence of pseudocode statements that we've written. If the condition is false, instead of doing the first action, we execute the else part. So instead of the then part, we execute the else part, which is a different set of steps that we've written down. We're the authors of the pseudocode program here. And we do that. So either the then part or the else part gets executed. It's never the case that they both get executed. And either way, we go ahead and execute the next statement. So again, the next statement shown at the bottom right of the slide is not part of the if-then-else. It's just the next line of pseudocode following the if-then-else. So now that we understand the selection sort of in its basic form, let's look at an example. So here's a pseudocode program, and it uses selection, and we're just going to go through and see how it works. So the first thing we do is execute the lines that are colored red now. So what the first line does is displays enter a number. And so remember, this basically means that as the human being executing the pseudocode, we should pretend that we read the text enter a number printed by our program. And then get number. Get is a pseudocode construct for getting a value from the user, that is to say us, and placing it into a variable in the pseudocode program. So number is a variable in the pseudocode program. And after the get number executes, the variable number is going to store a value that we gave it, whatever value we chose. So let's keep going. So now we have a selection construct. We have an if-then-else, and what we're going to do is look at the condition in the if-then-else construct, and the condition here is number greater than 0. So number greater than 0 is an expression in pseudocode, and remember that expressions are things that evaluate to some value. So a condition, or a Boolean expression is another term you hear this called sometimes, is an expression that evaluates to either true or false. So some expressions, like we saw a plus b evaluated in a previous lecture, don't evaluate to true or false. But Boolean expressions or conditional expressions do evaluate to true or false. And so number greater than 0 is either true or it's not true. And so, so let's keep going. So let's assume that the person executing the pseudocode entered 5 for the number. So now we have to evaluate the expression, number greater than 0. And how do we do that? Well, we look up the value stored in number, and it's 5. So now we evaluate the expression 5 greater than 0. So 5 greater than 0, as we all know from elementary school, is true. So what that means is we're going to execute the then part of the selection construct, and we're going to display it as positive to the user. And we're not going to execute, in this particular execution of the program at least, the else part. And so what we can see here is that the program has done something, that's in some sense true or correct. It's taken a positive number and it's printed that it's positive. And one thing we're going to see throughout this semester is it's pretty easy to write programs that do something that isn't what we intended. But at least so far, this program appears to be doing what was intended. So let's look at another execution of the same pseudocode program. So now instead of entering 5, the person is going to enter -2. So now the expression number greater than 0 is going to evaluate to -2 greater than 0 because -2 is what's stored in number. That evaluates to false. So we're not going to execute the then part of the selection construct, but we're rather going to evaluate the else part, and we're going to display it is not positive. And again, we can see that our program has done something that sort of is in some sense true or correct. That is to say, it has printed that -2 is not positive, which of course is true as we all learned. So let's look at a change to this program to make it not good. And the reason I bring this up is that we really, really, really want to start getting used to looking at our programs and seeing if they do what we wanted. So there's something that we always want to do when we're writing a computer program, and it's, maybe it's what I told you to do, or maybe it's what your boss told you to do, or maybe it's, you want to write a computer game. And then there's what our program does. And sometimes, as in the example here, the program does what we want it to do, but very, very, very often, as in the case here, the program doesn't do what we want it to do. And so what I've done here is change the else code so that instead of displaying it is not positive, it displays it as negative. And I would like you to take a moment and look at that change to the program and see if you can figure out why it's wrong. Okay, so let's talk about that. So if we give this program 5, it's going to print it is positive. So that hasn't gone wrong. If we give it -2, then it's going to print it is negative, and that's correct, right? -2 is negative. So what's the problem here? The problem is if we enter 0 when the program asks us to enter a number, and then we have to ask, is 0 greater than 0? And of course that's false. So the program is going to print it as negative, but 0 is not negative. 0 is not positive or negative. And so this program's wrong. And again, all of you in this course really need to start getting used to the idea that we all write code that doesn't do what we wanted it to do the first time. And you have to start getting used to looking at the code and trying to figure out what's wrong and what you need to change to make it work. And this is just fundamentally really hard. Working programmers who've been working for 20 years are routinely baffled by the behavior of their code. So this will be frustrating for you at times, and you just have to sort of embrace the frustration, I guess. I don't really have there's really unfortunately no better advice than sort of trying to learn how to get to the bottom of what's wrong. Okay, so let's look at the general case of selection. So the general case of selection is if condition, and remember condition is an expression that happens to evaluate to either true or false, then there's a true action, which is just a sequence of pseudocode statements, and then there's a false action but underneath the else, which is a sequence of pseudocode statements that get executed if the condition isn't true. And so one thing we need to be sure about here is that we understand that the pseudocode program is wrong. It's fundamentally sort of broken if we type something into the condition that doesn't execute to true or false. So we can see on the slide here, if we put something in condition, for example, set a to a+1, that's neither true nor false. That just does something. If we put if 5 was the condition, that's again neither true nor false. If we put display hello in the condition, again, that just does something. It's not true or false. And a pseudocode program that said if condition and then had one of these conditions, that would be a pseudocode program that's just wrong. It's sort of structurally flawed, and we don't ever want to write it. So we want to sort of start getting used to these kind of constraints that we have on what we can write in the program, and that's going to allow us to make the transition to real programming a lot easier. So another thing we need to mention here is that the question is, where does the true action end? I said that the true action is a sequence of pseudocode statements, not just one statement necessarily. And the false action can also be a sequence. Where do they end? Well, here what we're doing is we're indenting the code that wants to be grouped together. So all of the statements in the true action are indented out a little bit. We can see that they're indented out a couple spaces. And that's how we know that they're part of a group. And that's also how we know that the else, which isn't indented, isn't part of the true action or the false action. It's rather part of the selection construct that we're using here. So let's look at one more quick example. Here we have a pseudocode program, the first line it executes is get num, so that reads a value from the user. The user chooses something and stores it into the variable num. Now we have a selection construct. We have an if then. It's not an if then else, right? There's no else here. And if num is less than 5, so that's a conditional expression, we can see that it properly evaluates to either true or false whenever we evaluate it. So this is sort of an okay program so far. The then part of the selection construct displays the number is less than 5, and either way, whether num is less than 5 or not, we display this message as always printed. And so what I want you to do now is sort of get used to the idea of executing these pseudocode programs. If they're simple enough in your head, if they're not simple enough to execute in your head, then you'll also need to use some paper to store values of things and maybe store where you are. And once we can do that, then we're really, really ahead of the game. We're really sort of well on our way to being able to write programs that the computer will execute. But we really don't want to deal with that quite yet, so we're going to keep talking about pseudocode a little bit longer. So just to recap, what have we looked at in pseudocode? We've looked at variables, which are just containers for values. They store a value like a number. We've looked at assignment, which is how we take a variable and change what's stored in it. And when you assign something new into a variable, it just forgets, it loses whatever was previously there. We've looked at input and output, which are a little bit silly in pseudocode because they're just input and output with a person who's executing the code on paper. But it's a legitimate part of the program, so we need to sort of think about it. And we've talked about selection, which allows us to execute code conditionally based on things that might or might not be true. And we're going to keep building on pseudocode, but this is where we are for now. Thank you.